Morning, Year 9. Going on with our topic trigonometry, we're up to lesson 4. Looking at lesson 4, our learning intention is to define the trigonometric ratios. Now, success criteria, what will you be able to do to show that you have mastered this learning intention? You will be able to identify the hypotenuse, adjacent sides, and opposite sides with respect to a given angle in a right angled triangle. What that means, if we mark an angle, say as theta, you'll be able to say where's the hypotenuse and which one's the adjacent side with respect to that angle and which one's the opposite side. And then after that, you're going to be able to, I can define the sine, cosine, and tangent ratios for angles in right angled triangles. And the last thing is that you're going to understand that trigonometric ratios are constant for a given angle. And you're going to understand that from similar triangles. We're going to look at similar triangles. Similar triangles, remember, the same shape, but they're different sizes. And from that, we're going to see that the trigonometric ratio is constant for a given angle. Okay, so we are in lesson 4. So our learning intention, was there or not, is to label the sides of a right angled triangle and write the trigonometric ratio. And that probably wasn't what I had written up here. Okay, so I should probably change that one day. But let's go back here, trigonometric ratios. So remembering our right angled triangle, remember our right angle, this one is called the hypotenuse. Now, the other ones, if in relation to theta, so that shape there or that letter there is a Greek letter theta. We use Greek letters to represent unknown angles in maths. So it can be alpha, beta, gamma, delta, theta, a whole heap of different letters. We generally, just to make it very clear, we generally use a Greek one for the letter, for the angle. So this one here is just an angle theta. Now adjacent in English means next to. So the adjacent angle is the one, or the adjacent side is the side next to the angle. Opposite, as we know in English, is another thing of saying is facing. So if you're opposite somebody, you're facing them. This one here is facing or opposite that angle. If we move theta up here in the other position, then our hypotenuse stays the same, obviously, because the hypotenuse is always opposite the right angle. But now that the theta is up here, the side next to it is this one. So this side is now adjacent and this side is now facing it. So depending on where we put theta is going to depend on which one we label A and which one we label O. Now, there are a couple of different ways of trying to remember this. The one now that we seem to be looking at, Mr. Gill came up a couple of years ago, and I think it's also in our worksheet. If it's to say A, if we say the angle is, A is between the angle and the right angle. A is between the angle and the right angle, and O is the other one. That is sort of the easiest way to remember it. So A is the side between the angle and the right angle. We'll put that there. O is the other one. So let's have a look for a minute at these ratios or at these of the sides, the ratios. So between the different sides. Sorry, I'll try and get there eventually. Let's have a look at these triangles. Now what I've done is I've just put this angle here in theta and I've just done it on grid paper so you can see this side is 4 squares, this side is 3 squares. And then if I come out all the way out for this outside triangle here, this one, then this was is 8 and this is 6. My triangle out here is 9 and 12 and so on. So I get a series of triangles here, which are all similar triangles. And the reason I know they're similar is because this angle is common to them all. These are all right angles and this angle is the same. So, and we can see as I increase. If I double this triangle and go from 4 to 8, this side doubles from 3 to 6, this side doubles from 5 to 10. I can see the ratio between them all the same if I have a look at the 5 triangles I've written there. So my 5 triangles opposite over the hypotenuse, remembering the opposite one is the facing one. So theta down here, my facing one is 3, my hypotenuse is 5. If I go to the next triangle, my facing is 6 and my hypotenuse is 10. If I have a look, next one, my facing one is 9, my hypotenuse is 15. Going further, my facing is 12, my hypotenuse is up here at 20, which I didn't write on there, a little bit slack. And then my last one, 15, and the hypotenuse is all this way here, 25. So those ratios, we'll look at them, I'll put them in my calculator to tell me, but we can see here 6 is 3 times 2, 10 is 5 times 2, the 2 can disappear, we end up with 3 on 5. Next one, 3 times 3, 5 times 3, divide them both through, 3 on 5. The ratio we put in our calculator, we look at it each time, is 3 on 5. So the ratio does not change for a given angle. As long as theta stays the same for these similar triangles, we are ending up with the same ratio. And that ratio, okay, so that's the first thing we just want to look at now. Again, I can do the same exercise which I've done if I use the adjacent one, which is the one that's between the next one. This is the same exercise. I've got 4 on 5, then I've got 8 on 10, 8 on 10, I've got 12 on 15. You can see it's the same exercise. And so the same exercise when we go through is we find the ratio is 4 on 5 for all of those. And then, so that is adjacent over the hypotenuse. And then if we do the opposite over the adjacent, a similar thing, opposite over the adjacent would be 3 on 4, or would be 6 on 8, or would be 9 on 12, etc. So what we find is the ratio of all those sides stays the same, which is what we expect. We know that's what's going to happen. If we double a triangle, it's the same shape, all of our sides double. If we triple it, they all triple. So the the ratio between the particular sides stays the same. Okay, so that's the first little bit. I've got to go through there pretty much simply going through that because it is in our learning intention. It's how I'm meant to. You're meant to understand that one of the points in the curriculum, that the trigonometric ratio is a constant for a given angle, and you're meant to understand that from similar triangles. Now that you understand that, you're probably not going to use it again, or certainly not right now. If we come down here, now we're going to define these trigonometric ratios. So for a given angle theta, the ratio of the sides of a right angle triangle constant. So sine, and what we write is an abbreviation. We do them abbreviate them all with 3 letters. So I read this not as sin but sine. And sine theta, so it's related to that angle. We're always going to have an angle in there. Sine theta is the opposite over the hypotenuse. Now that's just been defined that way. It's just defined, it's just labeled, it's named that, okay? So, and what we're going to use is sine is opposite of the hypotenuse. So S is O on H. And if we get rid of that, we've just got SOH, S-O-H. And so if we go from SOH, we're going to be able to go back to sine equals opposite on hypotenuse and go back the other way. Our next one is cosine. So the cosine, co is together with, so cosine just means together with the sine. The other one that goes along with the sine all the time is the cosine. So cos theta is equal to the other side over the hypotenuse. So C equals A on H, cut. And then finally the tangent. Now the tangent is different, you might say. Now a tangent is our rise over our run as well. So it's a gradient, but we're not going to get into that for you guys. Tangent is our opposite over the adjacent. It's not over the hypotenuse. It's the side that's facing the angle over the side that is next to the angle. So we've got T equals O on A, or TOA. So our great big thing that, well, I don't even think I should have written up here all over the place, the thing that we learn all the time. Looks like I haven't put the poster in there. I will put the poster in there. Is that we are going to have so, ka, toa. And that is what sock toa is. It's just all these letters chucked together. All right, so let's have a look at an example here. I'm asking myself or being asked to label the sides of the triangle with respect to the angle theta. Now theta's in here. So what I'm going to do in the first place, A is the angle, A is the side between the angle and the right angle. There's the angle, there's the right angle, so that one's A. A is between the angle and the right angle. O is the other one, and H is the hypotenuse. So we can find the hypotenuse now that we've been doing Pythagoras' theorem for a fair while. And now example 2 is to write the trigonometric ratios in fraction forms for each of the following triangles. So it's asked me for cos theta. Cos theta is A on H, which is the A, my angle between the theta and the right angle. There's theta, there's right angle, so that's A. The number is 5. I'm picking up that 5. And then the hypotenuse. The hypotenuse is over here, and it's at 7, so it's 5 on 7. Looking at the next one, I'm going to find the sine theta of that angle. There's theta there. Now sine equals opposite over hypotenuse. Opposite is the facing one. But if I label them all in the first place, I'm going to have, if I keep just doing the same every time, the angle and the right angle. A is between the angle and the right angle. H is the hypotenuse. O is the other one. Now I'm looking for O on H. The value of O is 4. The value of H is 9. Last one, I'm looking for tan theta. Again, I'm going to label them all first. Find theta. There it is. Okay, so A is between the angle theta and the right angle. There's A. Find the hypotenuse opposite the right angle. There it is. And then O is the other one. I've got them labeled. Now, TOA, tan theta, TOA. Tan is opposite over the adjacent. Tan theta, O, the facing one, is 3. H is 5, 3 on 5. So today what you're going to do is you've got 2 worksheets here. This one here, you're just going to go through and keep putting O and A on them all. You don't even have to put the H on by the looks of it. They're just, or some of them here, you do have to put the H on. Other ones have already. So this one, label them O as O, A, and H. And they've called it the angle is always held by A and H. So very similar to what Mr. Gill said. A is between the angle and the right angle. Okay, so just label the sides here with the numbers on them. So I guess this sheet is suggesting that you don't confuse yourselves and you only put the angles down. The second sheet is where you're going to write down sine theta, tan theta, and cos theta. Okay, good luck with all of that.